So now I want to talk about the great disruption that led to, in a sense, the NoSQL movement and started changing database architectures forever. So prior to this, let's just pick 2002. Everybody had their own relational database. Everybody bought a $40,000 computer if you had a big school like the University of Michigan. Everybody bought a $40,000 computer and ran your database for your HR on a $40,000 computer, ran your database for your mail on a $40,000 computer, and just vertically scaled it. And it worked because the software worked in this environment, the hardware worked in this environment. It was not cheap to do it, but it was something we needed to do, and away we go. And so there, again, a lot of what I'll call pseudo-cloud vendors use this as their technique, and that is to just make a bunch of databases, they put them all in Amazon, and they put the application in front of them, and then switch between databases and claim, we're cloud. And the answer is no, we just collected all of the individual ones and put them together in one building, or in a couple of buildings in the case of Amazon. So that's 2002. And what happened is Google. So Google's going to search. They're going to write a database crawler, and they're going to crawl the web, and they're going to make a full copy of the web, then they're index that full copy of the web, then they're going to look at like connections between it. Sounds like a perfect thing for a database because it's all about connections, just like relational, right? And then, of course, you have Gmail that comes quick on the heels, right? 2009. And that is, here's Gmail. Now, Gmail's are not just a read-only thing, well, read-mostly thing, but Gmail's read-write. We're going to log in and check our mail all the time and send a message and delete it and this, that, and the other thing. And so Gmail is very much like a typical application that would use a relational database, going back to how universities were doing it in 2002. But it could not. It just couldn't. Google was not going to give everybody their own domain, even though these days they've changed that. But let's go back to 2009. Everybody just used gmail.com. One of the things that was nice about Google was that they really chose applications that didn't exactly need transactions, that eventually consistency was fine. So think about Gmail, right? You got 100 million users and they're just logging in, but they're kind of logging into their own little data silos, right? And so the eventual consistency wasn't that I'm going to delete a message from your mail. I couldn't do that. I could only delete messages from my own mail. And then I would send and receive mail, but that was just kind of this ever little mail sending thing. And it was all nicely client server, and so my little corner of the world would send your little corner of the world a message, and then, a couple seconds later, your corner of the world would see my message, and vice versa, then you'd reply. And so Google worked in these cloud scale applications. And it was a chicken and egg problem in that they wanted to build these really cool scalable cloud scale applications, and so they couldn't do certain things. Now, you'll notice in the early days of Google, they didn't have charging. Because then do you really want any eventual consistency on an accounting system? I don't think so. You want to know I billed them or I didn't bill them, right? Or you want to be able to, if the bill came and you got an email about the bill, you want to be able to log in and see what the bill was, right? But it's an eventual consistency, so the bill's not perfect yet. And even writing to Gmail was widely distributed, right? I mean, like I said, there's just these little pockets of data. In the early days of Gmail, they would migrate your data to a server that was closer to you. Like if you went back home to Europe on a Christmas break, the data would sort of creep over to servers that are there, and your little island of data would just move around, and then all of a sudden it'd be really fast. So there was this data migration. Your little silo of data might follow you around the world as you traveled. And so the early Google applications were not Facebook, they were not Twitter, they were not connection oriented, they were just like, here's a thing for you and whatever. And so these systems used cleverly named files, used hashing, right? You can hash an email address, and that could be like a folder that has a bunch of files in it. Then you take the folder names and you hash them, and then you basically make it so that when you delete a file, it just rewrites that folder a little bit, right? And they even could use little bits of relational database if they felt like it. Something like SQLite, which really reads and writes one file on disk. It's not great for multi-reader, multi-writer, but if there is one database for each user, then SQLite could be a good little database, right? So sharding is the idea of slicing a problem across a bunch of servers, and then you sort of have your particular view. It's not like like a read replica where you could go to any of them. No, you had your email address and your data was on this one server. That's your shard, and so you've been sharded. So your data is not on all the servers; it's just on this one. And unlike the stuff I showed you before, there's only one. That's a shard. And so I want you to watch a couple of videos. You can either watch these on YouTube. This is an hour-long keynote. I've got a much shorter version of it that you can watch. This is Marissa Mayer, Google I/O 2008. I was actually in the audience when she was giving this talk, and I will tell you that my mind was blown as she was talking. You know, I go to a lot of conferences, and I'm always sitting with my laptop in the conference, and I'm like, get some code done, yeah, whatever, they're going to say dumb things, right? I mean, I'm enjoying it, and I'll clap once in a while, lift, and then I'll go back to coding. As she hit this part of the speech that I've cut out, my jaw just dropped. I'm like, and you're going to watch it here in, 2020 or later, and you'll be like, why was that so amazing? And the answer was that in 2008, Google, prior to this was the first Google I/O conference. It's the Google Developer Conference, which I encourage you to go to. They're kind of repetitive after you've gone to one or two of them. Went only to two of them and stopped going because they're so repetitive. Google, from a developer perspective, just it's crap. They just come up with an idea and then they throw it away just like 2 years later. So Google is really not stable enough for me to like as a developer. I like Amazon. I like Microsoft if you're kind of into that closed source kind of thing. But at Google, someday I'll just go be president of Google and I'll just slap those people. I'm like, quit it. Sorry. That Marissa Mayer, great keynote. Google I/O was like opening the covers to what had been for almost a decade at that point, completely the most secretive way of building fast systems. And I walked in thinking, as a high-performance computing person, that thought that $1 million computer was the way to solve most problems. And what she showed with this gather-scatter technique in this is like, oh no, she has a bunch of $1,000 computers, and they go so much faster than my $1 million computer, and she can add as many $1,000 computers as she wants. And I'm like, yeah, that's pretty dang cool. So it was revolutionary. So please watch it. Put your mind in the sense that this was, to me, the first time that Google was showing how it was able to do search cost effectively and not charge you for it. Because if I'd have built search in 1997, 98, I'd have built it out of really expensive hardware, and Google did not build it out of really expensive hardware. A year later, they started showing some of their actual techniques for how they build virtualizable hardware. And this is amazing. Again, before this time, I would see rumors about this is how Google does it. It was a big secret, right? And what happened is in 2000, it was a big secret. But by 2009, what people realized was, with the energy crisis and all these concerns about the footprint of the energy costs of these systems, and the fact that they would throw these things away after 1 or 2 years, and so everybody, Google and Facebook and Twitter and Amazon, they realized that for the greater good, they ought to share some of their best practices on how to do all these things efficiently. And so they started having summits. And so again, when I first saw this, I'm like, jaw drop. I'm like, that's their secret. Holy mackerel. I can't believe it. It's amazing. I would have never thought of it. That is not how I would have built Google. Not me. That's not how I would build it. But then you watch it and you go like, of course, what a good idea, right? And again, acid and base are the essence of this. And I was an acid kind of guy, right? And I was looking at this base world, and I'm like, dang, that's really cool. And then I also want you to see, and so you see this is 2010. So you see Google's kind of opening up their secrets to the world. How does even search work? So this is a Matt Cutts, March 2010. It's a beautifully done production with animation, but it's also, think of it from a acid versus base perspective of, how they can use a distributed set of computers to go through the web, to pull the web down, to index the web, and then to run searches. So I really want you to watch these 3 videos. You can either watch the short versions that I've provided, or you can watch the long ones. The Marissa Mayer is the only one where the long one is an hour and my short one is like 3 minutes. And so you got to catch the part where she talks about how to do searching. But the Matt Cutts one and the Google Container Tour, those, if you watch the long one, they're not that much longer than my succinct versions of them. So please watch those, and then come back and we'll talk a little bit more.